Today we will discuss about a simple problems. So, four forces of magnitude 10 Newton, 20 Newton, 30 Newton and 40 Newton are acting respectively along the four sides of the square ABCD as shown in the figure. Determine the resultant moment about the point A. Each side of the square is 2 meter. So, this is the figure and each side of the square which is 2 meter, right. So, we have to determine the resultant moment about a point A. So, now we are going to take moment about a point A, right. So, we know that moment which is equal to force into perpendicular distance between the force and at the point which we are going to take moment, right. So, how many forces? 4 forces are there at point A 14 Newton, at point B 10 Newton, at point C 20 Newton, at point D 13 Newton, right. Now, we are going to take moment about A. So, which means, so we can't take this 14 Newton, right. So, now is it possible to take 10 Newton? No, because so from A we can't measure the perpendicular distance between the point A and B, right. This is the perpendicular distance between the force. If you want to measure the perpendicular distance of this 10 Newton, this is the way, but we can't measure from A, so we can't take this 10 Newton, right. So, is it possible to take 20 Newton? Yes. Why? Because so we can take the perpendicular distance like this, right. So, we know that the distance which is equal to 2 meter from A. So, 20 Newton is acting anti-clockwise direction with respect to the point A. So, now the moment which is equal to force 20 Newton into 2 meter, right, which is and plus, right. So, plus then last force 30 Newton. So, we can measure the perpendicular distance from A which is 2 meter, right. So, with respect to A. So, this 30 Newton is also acting clockwise direction, that is why here plus 30 into perpendicular distance 2, right. So, this is 20 into 40, 20 into 2 40 plus 30 into 2 60, right. So, which is equal to 100 Newton meter. So, this is the moment of this problem, right. So, moment about A. So, 20 into 2 plus 30 into 2. So, 100 Newton, right, counterclockwise direction, right. So, this is, it's a simple problem, right. Then second one, two like parallel forces of 50 Newton and 100 Newton acts at the end of a rod 360 mm long. Find the magnitude of the resultant force and the point where it acts, right. So, this is the problem. At point A 50 Newton is acting downward, at point B 100 Newton is acting downward, right. So, the resultant force acting in between A and B somewhere which is C R, right. So, the distance between A and B which is equal to 360 mm, and now we want to calculate the magnitude of the resultant R and the point where it acts. So, from A we have to assume the distance between A and C which is equal to x. This x we have to find, right. First we have to find the resultant force R. So, R which is equal to sum of this 15 Newton and this 100 Newton, right. So, 150 Newton. So, this is the magnitude of R, and now we want to find out this x. So, for that we have to take moment. So, moment about point C, right. So, moment about point C, we know that moment which is equal to force into perpendicular distance. So, 50 Newton is acting anti-clockwise direction with respect to point C. This 50 into the perpendicular distance x, right. So, and with respect to C, this point, I mean 100 Newton from B is acting clockwise direction. So, both are opposite, that is why, which is equal to 100 Newton into the distance, which is equal to 360 minus x. So, distance between B and C, which is equal to 360 minus x. So, now this is 360 minus x, right. So, now this is 50x, solve this, and 36,000 minus 100x. Now simplify this, 150x which is equal to 36,000. So, x which is equal to 36,000 divided by 150, right. So, how much? 36,000 divided by 150, which is equal to 240 mm. So, which is equal to 240 mm. So, 240 mm, the value of x which is equal to 240 mm. So, the point where it acts, the total resultant force acting at 240 mm from A, right. So, distance between A and x, which is A and R, which is equal to 240 mm. The resultant force R 150 Newton acting downward at a distance of 240 mm from A, right. Then next problem, it is also similar to that. Three like parallel forces 100 Newton, 200 Newton and 300 Newton are acting at a point A, B, C respectively on a straight line ABC as shown in the figure. The distance R AB which is equal to 30. So, distance between A and B which is equal to 30 centimeter and BC which is equal to 40 centimeter. Find the resultant and also the distance of the resultant from A on the line ABC. This problem is similar to the previous one. Now, we have to assume the resultant R is acting here, right. So, the distance between A and R which is equal to, let us say, x. Now, we have to find R and the distance x from A, right. So, what is R? R which is equal to sum of all the forces, right, because all the forces are acting upward. So, 100 Newton plus 200 Newton plus 300 Newton, so which is equal to 600 Newton. So, magnitude of R which is equal to 600 Newton, we know that. Now, take moment about say this point which is equal to D, right. So, A, B, C, D, right. So, now take moment about D. Now, take moment about point D, right. So, according to this point, this 100 Newton and 200 Newton are acting clockwise direction and this 300 Newton is acting opposite direction, I mean counterclockwise direction. Now, take moment about D. So, first point A, 100 Newton is acting clockwise direction with a distance of x, right. So, 100 Newton into this distance, I mean the distance, perpendicular distance between point A and point D, because we are taking moment with respect to point D. So, now we have to take moment, now we are considering point B, right. Point B, this 200 Newton is also acting clockwise direction, that is why here plus 200 into, so what is the distance? So, here 30 and here x. So, x minus 30, right. So, x minus 30 is the distance between B and D. This is x minus 30 distance, right. So, this 100 Newton and 200 Newton both are in the clockwise direction, that is why plus, and this 300 Newton is acting anti-clockwise direction, that is why, which is equal to anti-clockwise direction. So, 300 Newton is acting at point C, and what is the perpendicular distance between D and C? Say for example, AB plus BC which is equal to 70, the total distance which is equal to 70 centimeter, right. So, this is 70 minus x, right. So, into 70 minus x. Now, simplify this, 100 Newton, I mean 100 into x plus 200x minus 6000, which is equal to 3 sevens are 21, 21,000 minus 300x, right. So simplify this. So totally 300 plus 200 plus 100, 600x, which is equal to 21,000 plus 6,000. So which is equal to 27,000, right. X which is equal to 27,000 divided by 600, right. So 27,000 divided by 600, which is equal to 45. So what is the value of x? 45 centimeter, right. So the resultant R is acting upward at 45 centimeter from point A, right. So this is the answer, x which is equal to 45 centimeter. Okay, thank you.